Hello, everyone. I'm Steve Nunn, the President and CEO of the Open Group, and I'm delighted to welcome you all today to this special event marking a significant milestone. Today, we are proud to announce the release of the OSDU Data Platform Mercury release. So what's it all about? Well, energy companies don't just face the economic challenges that all industries are facing as a result of the current pandemic, but they must also manage the transition over the coming months, years, and decades to a lower carbon environment. Key to the strategy of most companies is embracing the revolutionary transformation technologies taking us forward in the data-driven era. The first foundational step is the development of a common data platform and architectural design which underpins how the industry works with its data. Data that is easy to find, easy to use, and easy to trust will help open doors to larger opportunities to improve the way we work. By bringing data together in one location, the OSDU Data Platform will reduce costs, remove data silos across the industry, and enable innovation. The OSDU Data Platform Mercury release represents an important achievement by the Open Group OSDU Forum in a very short space of time. Not established until 2018, the OSDU Forum has accumulated nearly 200 member organizations who are collaborating together to accelerate innovation and reduce costs in the energy sector. With a standard data platform, energy companies will be able to drive innovation by integrating digital technologies and utilizing open standards for better decision-making. Looking ahead, this will be imperative to meet the world's increasing energy demands while reducing emissions. So this is indeed a significant day. Thank you for joining us. And without further ado, I'm going to hand over now to Philip Yong, the chair of the Open Group OSDU Forum, to tell you more about this exciting release.
Hi, everyone. I am Philip Yong. Welcome to our Mercury launch. And today, the OSDU Forum reached a major milestone. Many of us have worked so hard for the past 10 months for today. It is opportunity for us to celebrate the collaboration at the level we have not seen before in our industry. We thank the Open Group under Steve's leadership for providing such an open and effective environment for us. This is our agenda today. After the welcome and introductions, we invite Jens Moran, Vice President, DataWorks, Innovation and Engineering of BP, to deliver the keynote. Following the keynote, Johan Krebers will discuss the scope and content of the Mercury release. Then we will show 6 video demonstrations of applications and services that are available on the OSDU Data Platform. The Mercury is only the beginning. So we would like to share with you the goal of making the OSDU Data Platform the data universe of the future energy system. Johan again will present the Open Energy Data Platform. Then we will have a Q&A session before we close the meetings. This is OSDU timeline. It's a perfect time to reflect on our journey that started in March 2018. When we made initial contacts with other operators. 8 operators agreed in June of 2018 to collaborate under the Open Group OSDU Forum. The founding operators joined the OSDU Forum in August 2018. On August 22nd, 2018, Shell contributed its internal subsurface data universe, SDU, to the forum. The founding operators were aligned with the OSDU vision, reference architectures, and the ways of working during September and October of 2018. In August of 2019, 1 year after the inception of the forum, we completed the OSDU R0 release on both Azure and AWS. On August 22nd, 2019, Scalability contributed its open data ecosystem to the OSDU Forum. This certainly provided additional momentum to the forum. In December 2019, we completed OSDU R1 on both Azure and AWS. In May 2020, we released OSDU R2 on Azure, AWS, GCP, and IBM. Now here on March 24, 2021, we launched OSDU R3 Mercury release on Azure, AWS, GCP, and IBM. I have been asked quite a few times, why is this time different than the past activity and efforts? I think one of the key differences is agility and the speed. The forum believes that OSDU Data Platform can make a difference in shaping the strategic priorities of our industry, namely digital transformation and energy transitions. The Mercury release can be used as the central repository of all data and supports the scaling up of digital and advanced analytics program that translate data into business value. Now, we all had sophisticated data system for years, but we all struggle to connect disparate systems and data in an easily scalable way. The Mercury release gives the industry the beginning of an open and standard energy data platform through which we can capture value from improved efficiency and uncover new growth opportunities. I'd like to share with you the OSDU visions. For the past many decades, our industry has been very successful in running our business with an application-centric environment as described in the left-hand side of the pictures. However, this application-centric environment cannot be used to underpin the new data-centric applications. Therefore, the OSDU vision is putting data at the center of the energy industry. This takes several steps. Step number one is to separate the data from applications. Number two, remove the data silo and use the standard data schema for all data. Number three, implement metadata to enable search and discovery of data across all data domains. Number four, implement a set of application programming interfaces to allow applications to interact with the data. Additionally, the platform needs to be secure and managed. The core data platform with security and operational utility becomes the data ecosystem that supports rapid application development. This is a very simple way of sharing the OSDU vision. This has been a great collaboration. And so far, we have 193 member companies. The forum is still growing. During the Mercury releases, we have anywhere between 133 to 212 active software developers working on the software code base. And beyond the software development, we have between 57 to 107 staff working on R3 projects like testing, data loading, operating procedures, demo documentations, marketing site, etc. We also have 150 staff contribute to the technical subcommittees and projects. And we have more than 18 open group staff help on legal, certification, contracting, marketing, branding, recruiting, and onboarding of new members, forum support, and many other activities. Altogether, the forum spent over 1 million person minutes on WebEx meetings in the year of 2020. It amounts to 2,372 effort days on WebEx meeting alone. And most remarkably, the entire Mercury release has been done during COVID-19. And with this introduction, I would like to introduce James Moran to deliver his keynote. Hi, James.
Hi, Philip. How are you doing? Can you hear me okay?
I can hear you.
Very good, thank you. Will I take control of the slides?
Yes.
You have control, James, if you just move on to the next slide.
Thank you. Well, good morning, good afternoon to everyone. So I'm James Moran. I have the privilege of working for BP and leading a large data team within the innovation and engineering component of BP. We've had quite an interesting year as a company, which I'll get into shortly, but I would like to thank the OSDU Forum group for this invitation and the chance to speak. It certainly has, as Philip said, been a remarkable 2 years since the initial conversation started, certainly that I was involved with Philip. We were just talking before the start of this event about it doesn't feel too long ago that we first had our early conversations. I'm going to reiterate some of what Philip said and try and give you a view of what this feels like from the perspective of an operator. I'd like to give a little bit of a history of where we've got to from this point. So from a BP perspective, and like many operators, we've had basically a 40-year journey of digital componentry being built, different IT systems, many workflows being supported, but we have collectively created between operators and software companies very deep but somewhat siloed set of technologies. There's been some incredible developments that have been made during this time, but I think in the last 5 years we've had quite a significant shift, and I think there have been about 3 main areas where we have all, as operators, certainly looked to change the way we work. So I think the first is probably the influence of cloud technologies. Certainly from about 2014 onwards, BP was declaring cloud first, initiated a move away from its major data centers, and this opened the door to thinking about how we deliver, certainly infrastructure to start with, but then quite quickly how we may change the way we work, particularly in subsurface and wells, which is a heavy compute and a heavy software usage environment. This coupled with our need to digitize. So whilst we have got these deep scientific silos and a lot of applications that we use, the actual orchestration of these can often be quite hard. We have essentially started to expose, through the need to digitize, integration holes within these existing systems. But I think the biggest change, certainly from a BP perspective, and certainly at the point where we met Johan and Philip from Shell, was that there was a significant mindset change that we felt, both inside BP and with some of our fellow operators, that we sort of wanted to change the way we were sharing. So we felt like we had an opportunity, rather than build our own and incur a lot of cost, that we could potentially share what we were doing. And this was the thing, this was the strong catalyst for us at BP to really get involved in the OSDU. And as Philip said, I think the expansion of membership effort, the number of individuals involved, has been significant over the last 2 years. But it is really fundamentally based on the fact that we can gain more through collaboration and openness. What are the benefits from for anybody really getting involved in the OSDU? I think it's fairly unique in the industry, or it feels fairly unique, because it's setting us up in a number of ways. So from an operator's perspective, it does, the intention and the hope is that it reduces our overall development and deployment cost. I think key is that we accelerate capability. So not just from externally, but from the ecosystem that surrounds an operator. So software providers, academia, the opportunity here that any startups, we've been working with quite a few over the last few years, their cost to entry of a market is very high when they have to build out a data environment that supports their application. And so this lowering of the marketplace is another key aspect that we feel is unique with the OSDU data platform. It's also key that we maintain this non-compete area. This is at the heart of the OSDU, and this is what will power the change that we're looking for. And I think for all of us, we want to increase our digitalization pace and data sharing. We do share data a lot between operators, and I think an open system that allows for the data to flow seamlessly between companies, between providers we are sharing data with, will save us a lot of time and effort. And I think not least what we are enjoying most about the open group and the OSDU is the collaboration that's happening amongst the members and with our standards body partners. So it's good to see groups like PPDM and IOGP getting involved in this initiative as well. Fundamentally, though, we like this because of its scalability. And this is something I'll get onto in a moment with the way that BP is changing, but it's not being restricted in terms of how big or how wide this platform can really go. So to give you some idea of that, this architecture diagram is hopefully fairly simple enough to walk through. We have worked with the OSDU, like any other operator, to share the way we use our applications today. And the intention behind this is that it's a data platform, not a data store. So what I mean by that is that it's very data centric. The applications that feed from this are essentially secondary to this platform's success, in the sense that we want to make sure that not only is data available, but it's also enriched within this system. So the architecture is following what we are starting to see as a fairly common pattern for cloud-based data systems. It has the ability to ingest data from many different sources. It can handle structured, unstructured data. It indexes and provides search capability, and it has growing abilities to start to enrich that data once it's made available into the platform. Key to that activity is that the lineage of that data is kept. Many of us, certainly within BP, we share and use data from partners, and keeping track of the ownership is very important, and that's a key capability that the platform will provide. And it's secure and has the ability to be operated on in a DevOps model. So we want to make sure that this, not only does the platform itself grow in an agile fashion, but the way we use and implement it in a company like BP, that we can operate it with that in mind as well. We have an ever-growing set of data sources, an ever-growing volume of data to be captured, and the system needs to be agile to be able to cope with that. The other component part of this, given that it's an open source initiative, is that there is a lot of documentation already being written around the platform. If you visit the OSDU website, it is rich in API definitions, schemas, more architecture diagrams, and again, this openness is what's going to be key to its success. And finally, it's adaptable. So it works on, as Philip mentioned, a number of the cloud providers, and in due course, we'll have an in-country solution. So there are many places around the world where there is either non-access to cloud or restrictive situation in terms of their geography, and this system is adaptable to that situation. So as Philip mentioned, we have had a number of releases. I think the point to make here is that it doesn't feel long since we had the very initial release, which was only developer focused. We've had the initial donation from Shell. We've had significant donations in 2019 from Blueware and Schlumberger. And by the time we got to May last year, we had the first system that we installed at BP that we could start to play around with and get a sense of what the architecture would look like and how it would, how we could bring it into the company. It had some basic functionality, but it's fantastic to see today that the Mercury release is the first operational one. And as Philip mentioned, this has gone on during the period of COVID. Everybody's been working remotely, and I know the team in BP, which is growing from about 10 to about 30, if you include everybody in the Azure systems of record team that we have, are pretty excited about getting this up and running as soon as we can in the coming weeks. So I'll just give you a brief overview of what this has felt like over the last few years inside BP. So from over the last, I guess, probably more than 10 years, we have had, I would say, reasonable stability in the applications that we've been using within BP, particularly in the subsurface space. But in terms of storing our raw data, in terms of those applications sharing data, this has been a point-to-point connection world. This has made a lot of overhead in managing this environment and a significant amount of inefficiency amongst our geoscientists and reservoir engineers and general scientific community in progressing development of different fields. We had on-premise systems still in terms of where we were storing the data, and we were on a journey as well through into Azure with hosting of different applications. So we have a pretty complicated environment, and the story we have here is one of simplification. So we've been building out our own components inside Azure for the last few years with some vendor support. More latterly, we've gone as native on cloud as we can. And by this year, our intention is that we bring in the OSDU platform to augment the systems that we already have. But this is the OSDU is making us rethink a lot about how we deliver solutions with inside BP. And we are fully intending on re-architecting component parts of what we've built as we look to transform the way we work within the subsurface. So over the last year, we've had some significant changes to BP. It's just almost a year to the day that our CEO, Bernard Looney, announced that we would be changing significantly the purpose of our company. We've had 112 years of BP running essentially in the same way, with an upstream and downstream business. During last year, the company went through a significant transformation, and we have a new ambition, which is to be net zero by 2050 or sooner. And this transformation happened predominantly towards the end of last year from a staff and reorganization perspective, and the start of this year felt like the start of a new company. So this is fairly significant for BP. We are essentially moving away from being an international oil company, and we're moving towards being an integrated energy company. So within about the next 10 years, our aim is to increase our low carbon investment from about 5 billion a year, which is about 10 times what it is today. We're looking to build significant energy partnerships with greater than 10 cities, and we are looking to double our customer interactions to about 20 million a day, all whilst reducing our core business, that's oil and gas production, by about 40%. So a fundamental shift in our business model and a fundamental change in how we need to operate internally. And so to give you some idea, we have essentially three areas of focus. So we're looking to build scale in our renewables business. We're looking to accelerate the revolution in mobility that's happening, and also scaling up our presence in growth markets around the world. And we're looking to continue with our safe and reliable operations with a high-grade portfolio. These are the three core areas that we will be focusing on. And we have also three sources of differentiation. So we're looking to stitch all of these things together into integrated energy systems. We're looking to leverage our many years of working in different places around the world as an oil company, in our partnering with various countries, cities, and industries around the world. And core to this is our digital strategy. This is what we feel will power a lot of the change. So hopefully you can see, as a company pivoting its business model, how important connected data systems will be to support our customers around the world in the different solutions that we're looking to deliver. And to give you an example of a very recent change in our business strategy, we have recently started a new partnership in the North Sea. So the UK government has a commitment to net zero emissions by 2050, and CCUS is one of those significant approaches to decarbonize, and certainly in heavy industries. The northeast of the UK, as you can hopefully see on this map, has some of the most carbon-intensive industrial clusters in the country. So, for example, on the Humber, that's emitting about 12.5 million tons a year of carbon, and the Teesside industries represent about 5.6% of the country's emissions. So, if this partnership is successful, and the aim is to develop offshore infrastructure to store CO2, then we will have helped decarbonize nearly 50% of the UK industrial emissions. And core to this, the monitoring, the safety, will be our integrated data systems. They'll be critical to how fast we can develop this and how fast we can replicate this type of pattern around the world. And this is just one example of an integrated system that BP are looking to expand into. So what does this mean for the OSDU and for BP currently? Well, we are a company that has a twin cloud approach. We use both Microsoft and AWS. We largely split these two platforms between our production and operations business and the customer and markets business. And in both cases, we have a very progressive and well-engineered data hub. So we use our data hubs on those cloud systems for a lot of data engineering, modeling, analytics, our IoT, our geospatial and compute. And this is where we're starting to grow a lot of our machine learning capabilities. Our systems of record, we fully intend on maintaining some independence there. We see some opportunities to generate some IP, but also I think we will see opportunities to donate to open source initiatives. And the OSDU, whilst we fully support its start in the subsurface and wells business, hopefully you can see from the examples I gave of the way that BP is changing, that we also fully support its expansion into other energy types. So as the OSDU evolves, we are going to be fully behind its development. It's going to be a model that we want to apply across our BP business. And we want to make sure that we also support this to generate new markets. I said at the start of this talk how important it was that the OSDU was opening up the markets to all kinds of new businesses and academia. And therein lies an opportunity for a company that's looking to change its business model and accelerate into new areas. So I'll end on a note around partnership. So this is somewhat of a tenuous link, given that the OSDU is naming its releases after planets. But this sort of reminded me of some news that came out in the last month. So the NASA's Perseverance rover landed on Mars. I hadn't really realized this, but we have had, BP has had through its Castrol brand, a 60-year partnership with NASA in supplying lubricants to its various spacecraft. Now, I hope it doesn't take 60 years to get an effective OSDU data platform, but I think the point I'm trying to make here is that we cannot really do this alone and overnight. It needs a lot of collaboration. Also, I think our experience in the last few years around trying to accelerate our digitalization is that it's really about the people, the business outcomes, and the partnerships where we've seen the most success. And many of these initiatives that we've started really come down to how effectively our data foundations are instantiated, how well they're looked after, the standards that we use. And again, the OSDU is going to become a significant part of that for BP. So I'll end on saying thank you again to the Open Group and the OSDU for this invitation and this chance to speak today. I would urge all of our counterpart operators, our software vendors and cloud service providers, and everyone to continue to get involved. What's been achieved in the last 2 years is fantastic, but this is just the start. And with that, I will close. Thank you very much.
Thank you, James. And with that, I'd like to invite Johan Quibers to discuss the scope and content of the Mercury release. Johan?
Thank you very much, Philip. Can you hear me okay?
Yes, we can hear you.
Very good. Thank you much. Good morning, good afternoon, maybe good evening. It's Johan Quibers out of a sunny day even today. You won't believe it, but it's sunny over here. We're going to talk about what's all in the next 30 minutes, what's all in Mercury. And by listening to Philip you already heard, quite a lot of information about what actually is in the Mercury release. But we'll go through it in a little more detail. And let me go here. Yeah, this is really the summary slide. I'll only talk about a number of things because Philip had a similar slide, but not in graphics, but with dates. It really shows you the two files or the two models, whatever you call it, of OSDU. So Shell started with SDU, Schlumberger had their DES, and of course that came together in 2020 when Schlumberger decided to make their platform an open source platform. It really came together, but also input from other people. So it is more than input from Shell and Schlumberger. Also other components were added to this whole story, and I will talk about that during this presentation and also later in the sessions. But it's really, and we're really looking at where we are with R3 and what's important about R3. R3 is the first full child, we would say, of the marriage of SDU and Schlumberger DES. I mean, R2 already had parts of it, but R3 is the full come together of those two environments and other components added to that. And therefore, just importantly, because in principle, it is the basis for the future. And the second point, of course, highlighted, it's a production environment, the first production environment we have, and like highlighted by BP, really the IOCs or energy companies, as we call them, are quite keen to start rolling out these capabilities. So let's look at the four main components of the platform scope. First is cloud-based, and you heard that, but it's cloud-based, and that's important. It's public cloud-based, but of course we also support in-country. And for at least one of the providers, one of the four providers, IBM, already supports today also the in-country solution. The others will follow in the coming months. So all four providers will in the coming months also offer an in-country solution, which is important for several parts of the world. People often forget about it, but it is very relevant, and we must maintain an evergreen environment as well. And of course, we've got the public cloud available now on 4 platforms that can change over time. I mean, that's flexible, that can increase, lots of things can happen with that. It's secure and extensible. It is microservice based, and that makes the upgrade of the platform itself easier because it's more flexible. And also the whole security is there with, of course, you use authentication using your standards like SAML or OpenID Connect, and use authorization where our entitlements and obligation engine plays an important role. But that's really what determines who gets access to what. And especially in a platform like we have in subservice business, where we've got joint ventures, we've got very many different combinations of companies of the field level to work together. You really need a very extensive authorization environment where you can be very precise. Okay, this project between Shell and BP on the Shell instance, what access do the BP people have to that environment? So secure and extensibility, vitally important for this environment. Data ingestion and access. If you look at any energy company, by far most of the data is in the subsurface space. I would say maybe 90% or more of the data sits in the subsurface space. Therefore, data ingestion with metadata support, with looking at data quality, is vitally important, because a lot of time will be spent over there at the rollout to get your data from the many places we have. And of that data has not been touched for years. And now we're going to bring it together in this single data platform over time. And the high performance. Also in the subsurface space, you find a lot of compute power. You find compute power in the seismic processing. And of course, we're going to get together. We're going to, that world of seismic processing and the world of OSDU will be merged over time. To their distinct worlds, but they come together. So the whole integration between high performance computing and OSDU is important. And we have a project in that space looking how can we integrate high performance computing applications into an OSDU space. So all of these are very relevant in where we operate. This picture, if you've been working on OSDU, then I should be able to wake you up at 2 o'clock in the morning. You should be able to paint this picture. This picture we created, I would say 2.5 years ago, has not really changed. And the green part will work together. So green part is all about OSDU Forum scope. Yeah, within the center, your data platform services. Left to that, your data ingestion services. To the right, your security services. Yeah, and on the left, total is your in-country solutions. Of course, with operation support, with underpinned on your platform. And it's very important, and we heard already early this morning, an OSDU is not a data warehouse. It's a system of record. What does it mean, a system of record? It means that you store the data there, you master the data there. So whatever data sits in OSDU does not need to sit somewhere else. Yeah, and that's a distinctly different from a data warehouse. It's really the data where you master your data, you store your data, and therefore the gray part with all your business applications. And therefore, and the gray part is really where people can compete. That's why we're very grateful for all the members out there. And we're going to show you later a number of these applications which have been developed in the gray part. Because the gray parts, the more, the better. Because we really want to create a platform out there via that red API layer where people really, where the application owners can really develop an application once, and that's running for many people out there who are running the green part over here. So OSDU Data Platform is about the gray part, or is about the green part over here, sorry. And the gray part is really where people can compete and can offer applications via the marketplace of the 4 cloud providers. And you can go to the marketplace, or you can go to start.osduforum.org, as highlighted also. Go there, and you find all information, what applications are available, what's happening, and how can I get these applications loaded on my implementation. But that's really the scope we talk about. Keep that in mind, and we're going to talk about the different components. It's the same picture, or the same intent, slightly different worded. In the center, you see OSDU Data Platform Core Code. That's really your data platform services. You see on top of that, on the right, generic API. It's a red API bar on the previous slide. But what is special with R3, we also introduced so-called DDMS services, domain data management services. very important because they will give excellent performance to selective data types. And you see two examples over here. You see the one for wellbore data, and you see the one for seismic data. What does that mean? Take the one for seismic data. Under the cover, we're using OpenVDS, which is another building block offered by Blueware, and that was the first. Component we included in that was in 2019. In early 2019, we said, okay, OpenVDS becomes a core component for the data stores of seismic data of the OSDU platform. But those domain APIs are geared towards applications who need high-speed access to their data. So, and of course, the DDMSs are not there for all data, are only there where it makes sense because of speed and other reasons that you need them. So all data access providers and APIs, it's for everybody. Certain data types are also not in place, also accessible via domain APIs. And you see two examples over here. Now more will come over time, but they're also a key component of the OSDU data platform. And on top of that, you got your applications coming in via your RESTful APIs or other means in the case of maybe domain APIs, but normally come in via RESTful APIs. And on the bottom, we see the service provider interface. That's really where the 4 cloud providers operate, and underneath the 4 cloud providers. On the left, you see the different ways of this service being offered. Well, this will be offered as a platform as a service. Yeah, you can go to one of the 4 cloud providers and say, I really want to see this as a PaaS environment, platform as service. We also will hear about later PaaS and SaaS implementations. Yeah. So there are multiple variations possible, and that will increase on how you can make use of it. Are you a large operator? Are you a small operator? That all will make a difference. And on the right, it's important that the open source component, you heard about this, with R3, the common code of the data platform is open source. It's available in GitLab. That also will change the way we're going to grow this platform. And really needs the input from each and every of you to really make it successful with our shared backlog environment. So it will be very different than when you go to a supplier and say, give me release 4, release 5, release 6. Here it's up to us what's in these releases, when they will come out, etc. The whole release management is another interesting challenge we're going to get now coming up. This slide you've seen before, so I won't go through exactly the same stuff, but it goes from left to right. But on top, maybe talk about the workflows. By bringing data together into a single data platform, your workflows can be much broader. We come out of a world where workflow was maybe one discipline. But if you now look at what you can do with your data in a single data platform, you can have a workflow which goes all the way from field development workflow, all the way from seismic to production, yeah, etc. So it gives, and then the lineage which you heard about before gets much easier. So you know when you're in a well space, you can find out how did I get there. If you want to know today, if you're in a well space, how did I get there all the way back, it's a challenge. So, but the lineage piece is very, very important. And by having a single data platform, by having these workflows on top, because those are enabled by the single data platform, and therefore think about workflows, think about orchestration services. They all in a great part become vitally important to maximize the benefit of this environment. And as you heard before, our application will be very much microservices based, and you need then the orchestration services on top to really build out of that your business. Yeah. The rest is the governance goes from ingest to discover. Ingest, about at ingest we extracting, discover and enrich to extracting the metadata as part of data ingestion services, which is part of Mercury, which is part of the release now coming out today. We also extract metadata, because metadata is key to find the data back. So metadata is really very important to us. So metadata will be stored also in the OSDU data platform, and then we're using search, yeah, because search is also embedded in the OSDU data platform to find the metadata, but also the real data. So therefore, metadata is vitally important. We will further with utilities like the machine learning utilities in that space. You can further enrich your data extraction services or your data quality service. That's all part of data ingestion. And you heard before that there's lots and lots of data be loaded out here. It also tells you that that this whole data ingestion piece is vitally important because the amount of data and the many data types. If example, we're working with the operators on getting all the data types loaded with data definitions, we came to over 100 data types in this space. That's so unique about it because last night somebody said, oh, what's the difference between a finance environment and this? Well, in a finance environment, you won't have 120 or 100 data types. Here you have them for good and bad reasons. That is not always good reasons because often there's also proprietary stuff out there which will start reducing. That's why things like OpenVDS. Deliver, of course, we talked about that. Secure, we'll talk about it more, but secure is all about data. It's about user authentication against the company IDP and user authorization. Vitally important here. And of course, operate. This becomes a crucial platform. And when we really roll out the OSDU for your various data sources, it becomes the prime platform you have in your energy business. The prime data platform you have in your energy business. Be well aware of that. So that whole operate mode is important. It's vitally that we think about it. And also we spend time with it. As part of Mercury. As part of Mercury, there are operation procedures out there. Yeah, if you worked, if you've tested, there are of course still the basic ones like backup restore, like logging, like monitoring, like release management. They're all included in the package. So Mercury is more than just a piece of code. It's also the service around it. And we'll talk about it later in one of our slides as well. But be aware of that. So what's new in Mercury? Extend, integrate the platform core. Yeah, that's with schemas. Yeah, making sure that it supports different ways of working. Your joint ventures, your IOCs, your national oil companies, that these are all being properly supported is vitally important. So that's really what you find out here as well. Yeah, and then of course support for the various units out here. Yeah, it's part of it. And then I'll come back on these in a moment. Then your data, ingest data easily, your data ingestion services, with both manifest and CSVs, but and later also we're going to add to that analytics, data ingestion will come up very soon, and integrate apps with use domain services. And we spoke a little bit about that, but I'll speak a little more about it. So these are new items with Mercury. So extend and integrate data platform, core platform, and I'm going to explain it in a moment. The whole data ingestion services and the whole support for fast access to data where that is needed. So we're going to go through these things now. First around there will add new domain and sources easily. You see some examples on the right, but of course you can easily add to this your fluid, your rock, your new energy, your CCUS you heard about. They all can be added to the OSDU schema. The R3 schema, which is the first time delivered as part of this Mercury release, be very clear, it's a major change between the previous release R2 and Mercury is around the schema. It's a big change. We have a lot of flexibility, so we can grow this into other energy sources out here, as mentioned a moment ago. So that whole schema service is important to give you flexibility for now and the future. This is all about having your data partitions. I can grow this OSDU environment into different environments. I might have different partitions sitting next to each other, but being well protected with my entitlement obligation service. I talked about that before. We have an entitlement obligation service in Mercury, which is based on an open source standard, OPA, the Open Policy Agent, yeah? And that really drives who has access to what, depending on roles. If this is your role, what data can you have? What elements of the data can you have? So it's really about, so you can grow this platform almost endless, between quotes, in different partitions. Because you might want to say, hey, I'm going to separate this data, because this is a joint venture activity in my company. I'm going to separate the data out, because I really want to make sure that only can be accessed by certain people. I really want to make sure it's highly confidential, or whatever it is. Yeah. But you get, this all part of L3, the flexibility is now there to make that all happen. So your data partitions, read about it, and entitlements, the ENO service, which will be part of Mercury as well. And of course, handle units, coordinates, and in data. Yeah, we have a unit catalog with lots of conversions out there, and a whole coordinate reference system. But again, important to avoid that people do their own things. It's really important that we have this part now as a core platform. Yeah. So these are all these things. These last 3 slides is all about how to extend the core based platform in Mercury and make it really enterprise ready. Yeah, we need operations ready, as we want it to be now with Mercury. And then the data ingestion. On the left, you see data ingestion, and again, we've got 2 elements as bit packaging as part of the Mercury solution. We have the data loading services, and the data loading service is all about you have your data sitting all over the place, how to collect that data, and create a manifest out of that or CSV file, and then load that into the data ingestion service on the left over here. And then the data ingestion will look at extracting metadata, look at data quality. You can add your own routines to that, and then it ends up at the top in the Mercury core platform. That's where the data ends up. And on the right, you see also how to get data out of this environment. Yeah, but data. So you have 2 components. Remember, data loading gets the data from all over the place, creates a manifest out of that, and you might have your own ETL service in there as well. And then secondly, the data ingestion services is going from that manifest into loading it into the platform itself. And then the domain data management services I explained a moment ago is vitally important. Yeah? And they're being added as part of Mercury, and more will be added over time. Think about your production data. We've got lots of time series data. Or say with wind farms, you've got lots of time series event data. We're looking also at DDMS service for that. So it's really meant not for everything. So your standard API is still the one you know about today. It's not going to change. That's still the API which gives you access to all pieces of data in the data platform. But if you say I need performance, I really need excellent support for real-time data, then we offer these DDMS services. And of course, because it's an open source environment, you can say, hey, I really need a DDMS server for this data type. Of course, you then discuss it with the PMC. Does it make sense? Can we combine things? How is it going to look like? But it's part of this platform. It's a key new development, which gives you a lot of flexibility. And your example over here, that's the Wellbore DDMS. On the left, you see the RESTful API, the application on the left, but REST. Then you see the first part of the Wellbore DDMS, and then you see the right part, which is in the core platform, where you see where the data is being stored. It's very possible that on the right, because it's special data, we will extend the OSDU data platform inside OSDU data platform with special data storage services, but they're all part of the data platform. They're not separate, they're part, and they're hidden to the applications. It's all accessible via an API layer out here. That's it. And then you've got your manipulations and other activities over here in the middle over here. Yeah. So this is one example. As I mentioned, we've got more examples available. So remember, extend and integrate the platform core with the partitioning, with the ENO, etc. And with the schema, with the R3 schema support. Important. Ingest data easily. Remember your data loading, data ingestion services, and apps and domain services. All 3 are new in Mercury, are key differentiators for these type of platforms. Documentation. If you go to OSDU Forum.org, you find lots, and you click there on R3, on the first screen on R3, you have lots and lots and lots and lots of documentation. In addition, you have these standard guides becoming available. Some that are available, some that are fully available, some are under review, and they're meant for the members out here. There's a lot more information available than this. Just go to osduforum.org. On the first screen, you say R3, want to learn more, and you end up in an environment for R3 where you find all the documents we have, some that are always complete, but every piece of documentation we have, when you talk about data loading, when you talk about DDMS, when you talk about something else, the architecture, it's all there. Of course, all the information is there for you to be successful. You saw this. If you joined before 9 o'clock, if you joined before 9 o'clock, you realized How many people are involved in this? It's all hidden. You never see these people. That's why we introduced that video. We see the pictures of people all around the world. I can say all around the world. It goes from China to San Francisco to Africa to Europe, you name it. So there's people from all around the world work together, often in difficult circumstances because of the COVID environment. So this is it's really them the people behind, and how did they work behind that whole story? First, on the left, we look at R3, look at horizons, yeah. And you saw the slide from Philip earlier. The first development release of R3 was R3 M1, became available in late October last year. Then M2 came out, and M3 came out, and M4 came out last week even. And the M4 is the basis for the R3 production release. And we're planning M5 coming out. So these are all incremental releases. And we really go to a model with OSDU. We go to a model of many minor updates. Those updates are backwards compatible. They will just be deployed. It can be once a day, 10 times a day, 50 times a week, whatever comes out of the shared backlog environment. We will not go for big releases. We'll go for many small releases. It's all backwards compatible, which we expect to immediately be deployed at the operator side. No long-winded review processes. No, it's like in SaaS and a PaaS environment. It goes out on the spot when we make them. Of course, fully checked, of course, that we know they're going to operate. And that's also the picture on the right says. Of course, we can't have it's an open source environment, but of course there is some structure around it. But the structure is very light because it's very dependent on people's imagination, people's ideas for us to be successful. It also gives an idea how many activities you see on the top, the authors, and on the top you see the commits. Gives an idea about how many active people are actually authors out there, how many commits are being made. It's real stuff. It's not phony. It's not vaporware. It's real stuff. People have been working it. Be well aware. Since September 2019, the cloud providers from Schlumberger and other people have been working to create OSDU R3. Of course, we first R2, R3. So we started a year and a half ago, where people had to pick up code which was not open source to make open source code of it. That's all be happening in the background. You never heard about it. It was just happening, and lots of people have worked very hard on this to make that happen. And as I said before, Mercury is more than a piece of code. You got to crop the data platform in the middle. Yeah, that's really what we've spoken about. But there are lots of activities around that to really the services. We talk about documentation, your marketplace where you can store, where application people can load their new applications. You've got training services, yeah, your development services, your EDS, external data services. So this is the green part. These are all services being offered as part of Mercury. And of course, in the blue part is operations offered by the 4 cloud providers. Yeah, and other people are going to hear about in the next session. So also be well aware of that. So the blue part, it is more than, oh, you got some code thrown over the fence. No, it's code plus services plus operations around it. It's important that you go for the whole stack and really enjoy the whole lot and not parts of it. It's important, especially in the beginning, that we take that approach. So we also have the famous, or at least within the team, the famous pre-shipping service. You won't have heard about it, but we created a couple of months ago together with the cloud providers what we call a pre-shipping assurance service. That means we've got separate environments from Amazon, from Google, from IBM, and from Microsoft, which is a copy of a production environment, and that code is first being released to those environments. And we've got teams, and those teams are just people, you and me, are people, volunteers from all around the world, from many companies who are actually doing the testing. They've been sweating over the last couple of weeks to test all the operation services. Does backup restore work? Does monitoring work? Does logging work? Does the admin UI services work? Yeah. Does E&O work? And that's not looking at a piece of paper, really testing. Does it really work? Ask the people who do the data loading testing. Spoke to them on Monday. They still got nervous on Monday because of many things happening in this space. Yeah. So these are real people, and the people are the members, nobody else. Real people doing real work to make this all successful. Will there still be errors in R3? Of course. Let's be realistic about these things. Or not R3, I should call it Mercury, of course. Mercury, yes. Let's be realistic. But we've done a lot of work to make it happen, and we've got an excellent support team out there with the 4 cloud providers and OSDU Forum to be successful, to help you getting started, getting moving forward, and all the other companies, the integrators out there, software companies out there. So get ready, get moving, and really go aggressively after this, because it's important also for you. Thank you very much. Now we go over to the exciting part. John, I think you're going to kick this off.
Thank you, Johan. I'm just handing over to Ollie. So we're now going to go to the application demos, and Johan, you're going to introduce them. So over to you, Johan.
So what we're going to do here now, we've asked about 2 months ago, we went out to all members, all focal points, say, hey, do you have application you want to show at the launch event? So we left it over, so we went to all vendors, they said, okay, we went. So we have about 13 companies coming back, say, yes, we have something. We have applications which are running on OSDU, on OSDU Mercury, or being tested for that, etc. And so what we do now, this morning, we're going to show this morning 6 of these companies, 5 minutes each, were they presenting their solution on OSDU. So 5 minutes each, and we have 30 seconds in between to do a short introduction. This afternoon we've got 7. So this afternoon 7 other companies. So if you want to see all 13, you have to come back this afternoon for the 13, or your evening, or your night, whatever it is. And now we're going to do the 6. This isn't, the first one is really the INT, and it's really an interesting one, because INT is one of our first people who got involved. And they really have an interesting application called EVAP. And EVAP is all about bringing all the data together, report the data, integrate the data, report the data, visualizing the data, etc. So I think it's an interesting application to see, and what you can do by bringing data together into a single data platform. Off you go with the video.
Welcome to INT's IVAP demo on OSDU R3. As you move your current legacy systems into the cloud, you may also be adding new applications, replatforming existing legacy applications, and adding machine learning and AI, all while connecting all these platform ecosystems to your OSDU platform. One question that remains is, how will you consume that OSDU data? Today during this demo, you will see how you have an option within OSDU to power OSDU visualization by leveraging IVAP's powerful domain visualization that has been developed on each of the cloud platforms, AWS, Azure, Google, and IBM. In this demo, we will discuss how IVAP can help you conduct all of the data exploration, selection, reporting, dashboarding, and viewing, but also integrate through its SDK, machine learning that incorporates the different processing functions you have within your ecosystem. We will cover search capabilities within IVAP and how you can select and view specific domain data, for example, well log and seismic data, launch workflows, and visualize results, all within one platform. Let's dive into the demo. You can quickly search and filter metadata such as well information, name, curve, depth, top, seismic, horizon, fault, and more within IVAP. Simply click and drag to select wells to add them to your project. Then select a well to display that data in the dashboard. Display and correlate your 2D and 3D seismic data within the same dashboard. View horizons, faults, well trajectories, and more within the same 3D view. With IVAP, you can view your wells on any map using web map services, correlate more than 1,000 wells at the same time, and align to top, depth, track, and more. Display well-logged trajectories and map data together in one 3D display. You can integrate IVAP with your machine learning to create an end-to-end workflow. For instance, you select some relevant data you want to analyze or automate. You launch your machine learning, in this case from the Jupyter Notebook. You choose the computational functions. You run it. And voila, you can visualize your results. All this from a single platform. The IVAP Machine Learning and AI Connector offers a unique way to embed visualization into your application ecosystem using JSON forms through a dynamic UI according to the machine learning or program invoked. The IVAP roadmap goes beyond OSDU R3 and will support Reservoir DDMS, Production DDMS, Geospatial Consumption Zone, DWIS drilling, well delivery, and much, much more. IVAP's new integration capabilities with third-party workflows are a game changer in terms of reducing cost and accelerating the adoption of innovative technologies such as AI and machine learning. Leverage IVAP's powerful data visualization on OSDU for the energy industry.
We're now going to look at the next one from 47 Lining. You hear presented from Carla Cole. A very different previous one. Here's an example of an offering for maybe the small operator. You see an example how OSDU can be packaged for different ways of working. So you see how quite an easy demo how this can be done. So I hand over now to Carla Cole.
Hello, I'm Carla Cole from 47 Lining, a Hitachi Vantara company. I'm going to demonstrate the benefits and capabilities of 47 Lining Enterprise PaaS in AWS Marketplace by telling a story with this demo. Modern Operator Inc. has decided to use the Enterprise PaaS to quickly evaluate the OSDU Data Platform, launch a new AI-enabled multi-vendor interoperable workflow, and operate it in production. Our operator selects the marketplace link from the OSDU Forum catalog, reviews the pricing and licensing agreement in AWS Marketplace, and chooses Subscribe. Here, Modern Operator provides the information that enables 47 Lining to fulfill their subscription into Modern Operator's own set of AWS accounts. Modern Operator wants to evaluate assistive interpretation capabilities from a startup, Agile AI LLC, within their workflow. They chose 47 Lining Enterprise PaaS because they needed a fast, easy, inexpensive way for their subject matter experts to quickly assess how the OSDU Data Platform enables Agile AI's components to interoperate within their workflow. They want to use the new workflow in production, but don't want to commission a new internal operations team. They want 47 Lining to be commercially accountable for data platform installation, maintenance updates, and support. Similarly, they want Agile AI to be accountable for its components. They chose a push-button, pay-as-you-go, easy-to-procure approach so they can be up and running with development and production environments in a matter of hours. As Modern Operator develops workflow improvements powered by data interoperability, they manage all of their workload deployments through the Enterprise PaaS Management Console. The console provides a single pane of glass for their environments and all their workload deployments of the data platform, Agile AI components, and others. Health checks are consolidated into this integrated view, so any issues are immediately observable. Modern Operator is always in control of the workloads they request. They have decided to run a small, cost-optimized instance of the OSDU Data Platform in their dev environment and have enabled auto-scaling and set higher limits in multiple regions in prod. They can easily refine all of these choices when needed. In dev, they're running 2 different agile AI components because they haven't yet decided which will work best. Our operator can request new deployments at the push of a button. When ready, they can easily promote to prod so end users can use the workflow. Modern Operator wants strong operational and security boundaries between the data platform and applications that use it. They've used the console to configure distinct workload accounts for the data platform and Agile AI components. They can easily access detailed operational dashboards for each OSDU Data Platform deployment. 47 Lining provides maintenance updates to track the OSDU standard and hot fixes to keep workflows running in production when issues are discovered. Modern Operator wants the power, configurability, and security controls of a platform as a service running in accounts that they control with the convenience and cost efficiency of a SaaS. With 47 Lining Enterprise PaaS, their data never leaves their AWS accounts, and they always control who can access their data and applications. Modern Operator configures 47 Lining Enterprise PaaS to use their existing corporate identity provider, so they can easily choose which of their existing staff should be able to access the OSDU Data Platform and Agile AI Assistant in each of their environments. Modern Operator can permit their own staff and staff chosen by each of their commercially accountable vendors to access the data platform and related applications however they choose. With 47 Lining Enterprise PaaS, Modern Operator accelerated their OSDU adoption and quickly transitioned to value in production operations with workflows that span multiple commercially accountable vendors. You can get started now with 47 Lining Enterprise PaaS preview deployment available through the OSDU Forum catalog. 47 Lining Enterprise PaaS production will be available this summer based on the Mercury release. You can also take advantage of our consulting offer to jumpstart your adoption efforts. Thank you, and we look forward to continuing to work together to bring interoperability to the energy industry.
Thank you very much. And now we're going to look at something very different. And we're now going to look at a topic called Interica, where they have a one view solution, where they're looking very much at bringing a one view of data in various data sources. So it could be something you use initially very much because you might have data in OSDU, you still might have data in your on-premise environment, in other environments, and one view with that one view, and you might have heard in the past about that PaaS solution, brings together into a single environment. So now let's listen.
Interica has been a member of the OSDU for more than 2 years now and fully embraces its aims and objectives. Given Interica's extensive history in collecting rich metadata from geoscience applications, our aim today is to demonstrate new capabilities in integrating with the OSDU, which we see as a vital part of cloud working. We have to thank our partner AWS in creating this deployment. My colleague Jenny will now be showing to you.
Thank you, Simon. My name is Jenny Marr and I'm a Senior Engineer in the Interica Professional Services team. I want to give a short introduction to Interica OneView, or IOV for short, for some context, and then we can dive into our exciting new OSDU integration. Interica OneView delivers automated discovery, analysis and action across the petrotechnical environment, focusing on application projects and the supporting datasets used for seismic processing, interpretation, modelling and simulation workflows. IOV discovers data by scanning for petrotechnical datasets stored within the organisation. This could be on-premise or in the cloud, in both Windows and Linux storage environments. Once scanned, we can then use our advanced connectors to extract, liberate and normalise metadata and spatial data from over 35 applications and data types, which we are continually adding to. Once scanned, users can analyse the data which has been collected. This could be as a simple searching for what data we have on a particular AOI, or just, for example, show me all the projects that contain the Arcadia 1 well or my WACA 3D survey. Or it could be to analyse my application usage, user data footprint or impact of our data governance policies. Finally, Interica OneView delivers action via the PaaS data movement engine. IOV can take projects and datasets, copy, migrate and archive to and between a wide variety of storage solutions, from tape to disk to private or public cloud, object and blob storage, and these processes can also be automated using our Arbor automated rule-based action module. I want to now take you through a demonstration of Interica OneView connected to an OSDU instance and share how users can discover data in context and can compare and contrast this with what is available in different storage environments. In this example, we have data stored on-premise, in file storage in the cloud, as well as data loaded to an OSDU instance running in AWS, and also archive data stored in S3 storage. This could be S3 Standard, S3 Glacier, or S3 Glacier Deep Archive. Firstly, we configure Interica OneView to connect to an OSDU instance. For this demo, we have loaded some seismic data, but we could also load other data types. Now let's consider an example. I'm a geoscientist working in the North Sea, and I want to see what data we have over the Gulfax field. I want to see what data is available to me, where that data is, and if there is any differences between it. Now within the OneView screen, I can zoom in and out of an area of interest. I can also draw a polygon to search over a field, where I can see the results are returned to me. Within these results, I can see we have seismic data stored in Petrel, PaleoScan and Studio, and now also in the OSDU seismic data. Now let's look and see if I have any data for the ST0202 seismic survey over the Volve field. I enter a survey code into the filter chip. I then click Apply, and now I can see the results are returned to me. Now what I'm really interested in at the moment is the full offset of the depth migration. I can see it's available to me within the OSDU, and I can check the metadata to confirm its quality. The metadata is mapped and normalized to enable quick comparisons. I can see the file name of the full offset, and I can copy this and enter into the filter chip. Again, I can click Apply and see a refined set of results showing me where this file has been found. I then wonder if we have any more data associated with this survey stored in any of my projects. I can further explore the content of Petrel project data and start to see what related seismic products are available, and also if there is any associated interpretation or well data which is also available. Of course, Interica OneView can do much more than just support searches. Users can get a holistic view across environments. Looking at the charts, we can see how much data is stored in all of our different environments, which also now includes the OSDU. We can analyse how much data is being added to the OSDU on a regular basis, and build and save this as a report which I can review regularly. I can also compare other reports on other applications or data stores. As we extend our integration with the OSDU, our next step is to support ingestion of data directly into the OSDU and egress as well. We want Interica OneView users to be able to search across all of their storage environments, both legacy and new, and be able to copy, migrate and archive between any environment they choose. If you would like to know more about how Interica OneView works with the OSDU, please get in contact with us at info@interica.com. Thank you.
IP exchange, and then also tries to blend and tries to optimize the data coming in, using its temporary stored TDM. So you want to hear from Steve Cooper all the details around TDM and Quorum.
Hi, my name is Steve Cooper of Quorum Software. In this presentation, I'll discuss the benefits of preparing data for loading into the OSDU using a staging database. I'm also going to demonstrate the benefits of this workflow using the Energy IQ by Quorum Wellmaster database deployed to the AWS cloud to load and blend 7 different sources of North Sea data. Data will be loaded from many different sources into the OSDU. These data sources will typically be in different formats. They won't match in terms of key identifiers, structure, CRS, units of measure, and reference values. If the data is loaded straight into the OSDU without any form of preparation and standardization, it's inevitable that consuming applications are going to make crucial search and query mistakes. For these reasons, the staging area needs to be a critical part of any workflow for data loading. Quorum worked closely with AWS to deploy the Energy IQ software to the AWS cloud. We've got numerous standardized loaders out of the box to extract data and load it into the TDM Wellmaster from multiple sources. As we load the data into TDM, disparate sources are matched together, relationships are established according to best practices, unique identifiers are assigned to the master data elements, the data is validated and converted to standards for CRS, coordinate reference systems, units of measure, and reference data. With the data loaded, it can then be enriched through business rules that blend the multiple sources to a golden record, aggregate data to create summary values, and new data derived through the application of advanced algorithms. Working closely with AWS, we then developed an IQ Exchange agent to deliver manifests directly to the AWS implementation of the OSDU ingestion APIs. The data flows from TDM to OSDU are fully automated and synchronized on an ongoing basis to ensure data flows that are streamlined and data that is always up to date. Once the data is loaded into the OSDU, we're able to visualize the sample data through the Quorum search and dashboarding tool IQ Insights. This sample data is also available to third-party interfaces with the OSDU consumption APIs. To validate the data workflows and deliver a substantial sample data set for testing, we loaded 7 different public data sources covering the North Sea, as you can see on the slide. This data was matched, validated, blended, and standardized to create a clean, comprehensive, and high-quality data set that companies can use to validate their own OSDU implementations. It took a significant amount of effort to derive and build the business rules into the automated workflows, but we now have over 46,000 wells plus associated data, along with a significant number of logs, surveys, and tops that is available for other companies to test their implementations of the OSDU APIs. I'll now quickly walk through the process we follow to load the North Sea sample dataset, starting with the TDM Wellmaster. Here we'll look at the Wellmaster data for the UK portion of the North Sea that has been matched, validated, and standardized. We've also built in the rules to establish the correct relationships between wells and wellbores and assign unique identifiers to this master data based upon industry standards. Drilling down, you can see that we loaded well data from 2 UK sources and then blended this data into a golden record based upon configurable business rules. The golden record is what we feed into the OSDU. Looking at the data from the Darlin field, we've loaded a large number of logs which were primarily in LAS and DLUS format. We extracted metadata from the log header and the individual curves, which could be transferred as an OSDU manifest in addition to the raw logs. We also loaded several thousand surveys and processed them to determine the bottom hole location along with the individual stations in XY offset as well as geodetic coordinate location. Finally, we loaded large volumes of tops data for the wellbores. We aliased the tops to a standardized set of formations for accurate retrieval. The next step of the process is to transfer the data from TDM to the OSDU using the IQ Exchange agent that we developed along with AWS. We set up a background job that's based upon a query, whether it's a subset of the data or the total data set, to transfer the data that we see on the right there, wells, tops, surveys, and logs. We do a full base load initially, and we can check the results of our transfer. And then we configure the job to run on a frequent basis to capture any changes within TDM. The IQ Insights tool allows us to visualize data directly from the OSDU through the consumption APIs. IQ Insights is built on the Elastic technology stack and enables us to search huge volumes of data in real time and display the results on a grid, in charts and dashboards, or on a map. I can investigate data at a high level, and then once I've got the results of my query, I can drill down to visualize the content in detail. In this case, I'm looking at a wellbore path with the formation tops superimposed for data quality purposes. I can also plot the contents of the OSDU on a map. I can combine spatial queries and attribute queries to highlight the data that I'm interested in, and then overlay spatial layers to provide context and facilitate my search. In this case, I'm showing pipelines, blocks, and licenses along with a subset of the well data. The North Sea sample data that we loaded into the AWS OSDU cloud is available for operators to validate their implementation of OSDU. The next logical step for the operators would be to load additional public and commercial data sources so users have access to a single source of the truth. A final step would then be to blend in proprietary data that could deliver enterprise master data to the OSDU and other platforms to drive workflow automation and advanced analytics. In summary, this has been a short presentation on the benefits of using a staging database to load data into the OSDU. If you have any questions, please feel free to contact me at the email address here, and thank you for your time.
Thank you very much. So we're now going to look at ROC-QC. It's a ROC data management system, again running on top of OSDU. So we're going to acquire, do the analysis, use machine learning, and going to give some charts about results. And will be a live demo as well on top of OSDU, and it will be done by Ian Barron, the CTO of ROC-QC.
I will show you ROC-log QA, which fits into the Delphi OSDU logical platform this way, plugging directly into the APIs. And it fits into the OSDU data flow into the data lake platform area enrichment data QC here. And now we'll show you a live demo of it.
This is ROC Data Management's ROC-log QA. This is a native web app, Azure, AWS, GCP, and also native in terms of Delphi and OSDU. You can also run it on-prem if you wish. It has 5 logical sections to it. One is to acquire the data. Then we do a deterministic analysis of the data, and things that pass that get fed into the machine learning. And then the results of all of this are presented as spreadsheets or charts so that you can analyze your data in any way that you wish. Then the results of those you can feed into the heart of the system, which is the cleanup. I'll run through these. So in the data source part, you can set up multiple sources and it will go out and acquire the data from those sources, either based on triggers in the sources as data is loaded, or on cron jobs, or you can do it manually. When the results come back, you get a listing of all of the curve data that's been loaded. In this case, there's just under 135,000 of them, which you can filter and dice and look at any way you like. And you can go from here directly into any of the rest of the system, like feeding it straight into the cleanup if that's what you want to do, or deciding that, the system thinks this is bad data, I disagree, I'm going to flag it as being okay, which will remove it from all of the error screens. In the deterministic errors, we do simplistic things to check, if it's got no samples, there's not much point in going further with it. There's nothing to analyze. If it's got no units, then we won't be able to seriously analyze it against its partners and check that it's on scale or really is the curve type that it claims to be. And then there's various other errors that there can be in the data. At the same time as doing all of this, we go and isolate all of the duplicates. These are duplicates irrespective of what they're called or what well they're in. So here we see we have a tremendous amount of lithology data that's been copied between very many wells. And you can select the ones you want to keep and it'll delete everything else on you, or you can select the ones you want to delete. The machine learning results come back here. We have curves that are substandard for whatever reasons, and there can be very many of those. Here we've identified ones that are unclassified and where the ML thinks it knows what it is, so it's come up with a prediction as to what these curves are. Here we have curves where the ML strongly disagrees with the classification on them, and the curve data doesn't match the model for that curve data. So, for example, you get data that's been labeled as a gamma ray, but it doesn't resemble a gamma ray at all. Single value curves, negative value curves, these are curves which shouldn't have negative values. What is a negative density or a negative gamma ray? And on all of these, you can select the ones that you want and you can feed them into the cleanup. They go straight into the cleanup engine, and then you can go and remove the negative values and replace them with null values if you wish. QC, so if we looked at this and we said, no, we actually think that AC is perfectly okay, we could just have added a QC flag to it, and it disappears from the error listing here, and would find it under QC OK flagged, and if we want to, then we can take it back out of there if you want to put it back into the list of bad data. Looking at the data, once you got it, you saw these spreadsheets here. We also have dashboards. Here we've got a standard confusion plot showing the mappings or the differences between what the ML analyzed things are and what we thought the curves were. Here we have a breakdown of all of the curve data that is being analyzed, and this is live. You can turn these sections on and off as you wish. And as data is loaded in the background, this will all update. And you get, total errors and total curves, and whatever graphing capabilities you want to put onto your dashboard. Cleanup is the heart of the tool. Here we've got the things that have been put into the cleanup queue. We can go straight into an editor and we can select things from that queue, and it'll automatically fill in the units that are relevant for that curve that's been taken. And you can put whatever criteria you like in here. So for instance, if we had taken these from the negative values, we could have put in a -0 in here, and we could have told it to replace anything that was less than -0 with a null value, and that would be the null value that's specific for that curve. And this will run through hundreds of thousands of curves extremely rapidly and make all of the necessary changes and write the output out as an updated version of the curve data automatically back in OSDU. And you may not agree with the way that we set things up in the first place. You have the capability to go in and change your classifications or change or add to your unit mapping, so you can maintain the system and keep it alive. Very quick introduction to log QA on OSDU.
From Geologic, and Geologic is interesting because they bought a company called Subsurface IO, and that was the first, more or less the first, one of the first members of OSDU a couple of years ago. So we're going to talk about search and discover data. We're going to talk about standard data and third-party data, and how to manage and collaborate with their data.
Subsurface IO has worked with the OSDU community from the beginning as part of the founding Tiger team to build versions R0, 1, 2, and 3. In December 2020, Subsurface IO was acquired by Geologic System Ltd. and continues to strengthen its OSDU offering. Through hundreds of client conversations, we have discovered 3 main OSDU use cases. First, users want to search and discover their OSDU data. Second, they want to send data from OSDU to third-party analysis applications while keeping OSDU up to date with external data changes. Third, users want to manage and collaborate across colleagues, internal teams, and third-party partners and contractors to send and receive data while tracking where the data came from, where it currently resides, who has ownership, and who can view the data. Geologic's proprietary data management solution, powered by the Subsurface IO technology, enables all 3 use cases for the R3 Mercury release. Use case 1. Company Z has recently installed OSDU R3 and has connected the PDM front end to the R3 backend to enable its end users to search and discover data in the OSDU backend. A geologist has logged into the PDM front end that has been built upon a powerful GIS engine and flexible schema equipped to handle any amount of data and all OSDU data types. The geologist wants to find well log data located in a specific area of interest with a specific set of criteria without using IT or geotech support. Using industry standard selection tools on the map, she selects her area of interest and parses the data with a customizable set of filters and queries built out to the company's exact specifications. Geologic has enabled direct API access to PDM for the geologist's IT support and managers to customize these queries at any time as conditions and requirements change. An intuitive data manager GUI built upon an Elasticsearch backend enables the geologist to search at speed, pulling up queries that could take up to 5 minutes to load in the past to appear at most in under a second. Then, drill down tables and customizable charts, graphs, and plots let the geologist fully understand the quality, completeness, currency, and ownership of the data she is searching for. The Wellbore viewer enables users to quickly explore individual wellbores to view header information, documents, and other files associated with the well. Further analysis can be done using a variety of data-specific visualization tools like cross-sections, production plots, structural grids, and seismic viewers. If data needs to be merged or cleaned further, the geologist can load the data into a powerful data cleaning engine that generates new layers with the cleaned data marked with identifiable tags for further research, sharing, organization, and saving for future use. The entire process enables data search and discovery, cleaning, and front-end customization in minutes or hours that would have taken a team of personnel months to accomplish in the past. The second use case builds upon the first. The geologist wants to do additional analysis in her tool of choice, such as Petrel, Kingdom, Ares, Spotfire, and a variety of other software options utilized across oilfield teams. Geologic's PDM solution enables the geologist to do just this with a simple export and many options to move data from OSDU to industry standard tools in seconds. In addition, batch data migrations and updates can be scheduled and automated. For example, perhaps the geologist wants to schedule data to be sent from OSDU into, say, Petrel every Monday evening. When she logs into Petrel on Tuesday morning, the data will automatically be available, and any changes made to the data in Petrel will automatically update both in the geologic front end and the OSDU back end. Simple reports within the app report errors and document the success of each sending effort. A historical log of all activity is maintained for future use, data security, and management purposes. Finally, for the third use case, teams have requested the ability to both manage and collaborate with internal company users and external partners and contractors. In this case, the geologist wants to send data to another geologist in a different partner company, Company Y. Before this can happen, the geologist manager at Company Z has set advanced user permissions using PDM's robust user entitlement engine. This ensures no unauthorized user outside of the geologist and her enabled colleagues in the partner company will ever see data they are not supposed to. With permissions enabled, the geologist at Company Z selects the data of interest and grants access to her geologist colleagues at Company Y. The geologist receiving the data is notified of this newfound access with a simple pop-up alert and an in-app mailbox storing and organizing the alerts for when the geologist is ready. Geologic's PDM solution offers all of this functionality and more. A robust user entitlement engine gives the ability to set data access restrictions across users, teams, departments, and even companies down to a single wellbore data point. Our team at Geologic has built a modern, flexible, and intuitive front-end solution for the OSDU R3 release that enables users and teams to accomplish their goals in the top 3 use cases they have called for. To get started, schedule a free consultation today and learn how we can integrate with your OSDU instance and work within your unique framework. Contact us via email at pdm@geologic.com or via phone at 403-262-1992. Thanks for listening.
Okay, thank you much. So now we're going to talk about the last session. We're going to talk around what's the future of OSDU, the Open Energy Data Platform. We'll keep that relatively short because we also want some time for Q&A. So we've heard where we are today, the Mercury release, where we're heading for. And what we're heading for is really to make the OSDU, the Open Energy Data Platform, so where we can really connect to any type of energy data source. You heard it already earlier, we can connect to the current ones. We also have a program to connect to wind farm, solar, hydrogen, CCUS. And why is that important? Because then that's important because then it brings all the data you have from all the various energy sources into a single data platform. You can run your AI on top of that. You can do your predictions for the future. You can see what's the best energy mix for tomorrow or the day after, for the next week, based on all the information I have from my wind farms, from my solar farms, from my oil and gas fields, etc. So you can optimize everything from production point of view, but also from a delivery point of view. So that's what's important, to bring that data into a single data platform. So the better you can optimize that, the better you can predict for the future, the more efficient you can be. So that's underpinning, really bring that data together, a single data platform, and start adding to that also other types of data, which we're going to talk about in a moment. That's overall what we're heading for. And this is the picture you maybe have seen before. The blue part, with the gray blocks, the blue part and the red part is really the OSDU data platform. On the left, you see OSDU R3, OSDU Mercury release. Today, we're launching there exploration, development, and wells. In the middle, we're working with a project going on, talking about drilling, working on the upstream production piece, which we want to add late this year. And we're right, we've got a project actively going today on wind farm, on CCUS, and solar, and others to follow. All that data comes from various energy sources, but comes together into a single data platform under a single set of APIs. And on the top of that, you got the various applications, as you've seen before. There can be many different applications out there. It can be AI applications, it can be any type of application running on top of the OSDU data platform. And you also see the word edge over there, because we're also launching late this year an open source based edge capability, because increasingly we go to near real-time data, and then edge becomes important to really overcome things like latency. And remember, this is an open source based environment, and it becomes later this year a real-time based environment, where we're also adding a real-time data, a real-time engine to this setup. So stepwise, we're going to add extra energy sources. You saw it on the previous slide. We're going to add real-time support, which is important if you think about your wind farms, about your production environment, and even about the drilling environment. It's open source based. Your speed and agility, and anybody in principle can decide what will be added from a functionality point of view. It's open source edge capabilities. If you need facilities closer to the edge, like I mentioned, wind farm often needs an edge facility, open source with good interfacing with the OSDU data platform. And all the applications will be on the OSDU data, on the OSDU marketplace, from IBM, from Microsoft, from Google and Amazon. They all have their marketplace. So go to osduforum.org, where you find the catalog. And from the catalog, you can also see what application is available on which provider out here. It's all available. Have a look. So really, that whole open source is important to have from an agility and from a speed and agility point of view. It's very important there. We also have a project together with IOGP, with the International Association of Oil and Gas Producers, to also add engineering data. So your piping, your electrical, your instrumentation data into the same data platform. So it's a project we started with them about 2 months ago. So it's a joint activity between the OSDU Forum and the IGP to think, okay, how are we going to bring the engineering data into the same environment? And what you create then is the basis for a digital twin. Because what's a digital twin all about? You bring together your operational data sources, which you already have in OSDU, we talked about, and your engineering data sources, we talked about, and bring together into a single view. That's what we call the digital twin. That's what we're heading for, creating, underpinning that digital twin over time as well. So I mentioned over here the IGP, coming to that engineering data, come to that single digital twin. Remember as well, because people often forget, OSDU is a system of record. It runs your master data. That's where you store your data, not somewhere else. You don't take a copy from data somewhere else and bring it to OSDU. OSDU becomes the master and can take the other source away there. Yeah. We also are looking, okay, we talked about the new energy data sources. We're also looking at how to store GHG data in there, or how to store your ESG data there, your environmental, social, and governance data out there. Yeah. So these are all things we're looking at, how to further enrich this environment, because these are all data sources an operator will need. The other one we're looking at, maybe grid. Nothing is studied over there, but having support for electricity grids over there as well. So the grid has not started yet. Some other things also have not started, but it's really underway is production. What is underway is wind farms. What is underway is CCUS. What will happen, what will be underway very soon, is solar and hydrogen and geothermal. And then of course I spoke to you about adding the engineering data there as well. But what you see is bringing that single data platform for all open energy related data and related data. Because the whole story about GHG is very important, and related data in the same space as well. So what's important from a business point of view? It's really have that data together into a single data platform, so you can make better predictions for the future. And the more accurate your prediction for the future will be, the more cost efficient you will be. And it becomes quite important in the future because the margin will be very different from where we're coming from. So if you have good data being brought together, you got good AI applications on top of that data, on top of the OSDU Data Platform. You have a fast environment, a very agile environment where the data cuts, where you get the result sooner than your competitors, and also better predictions, because better prediction means lower cost and higher margins to you. So it's all about data, 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 not just your own data, but as you heard before, increase also external data. Think about the wind farm, your weather data, all obvious data, but it all needs to come together for your AI applications to do a better job for you as the business. This example over here, very quickly, this is how you would connect, and this work in progress, how you connect offshore wind farms, so wind turbines, wind farms, into an OSDU environment. And you see, we need that support for real time. That's why we do the work with the Kafka engine. We need to support new data centers, like the IC data centers are important in the case of wind farm. These are all things, work in progress, being worked on how to make that happen. So we are really on the move from what we're launching today. We see that whole work for the future. And you heard from the BP representative how important that is to move into that future over there, because we're all moving that future over there. So my last slide, OSDU, what's it all about? It's API driven. Your clear separation between your applications and your data. And you heard about two types of data APIs, the ones we got platform wide and the ones related to DDMS. It's open source based. Lots of agility, a lot of freedom, a lot of flexibility, a lot of responsibility as well. And the OSDU Forum owns the data platform, not one supplier. The OSDU Forum decides what are the data definitions, what's the API all about. And we make this an open energy data platform with support for all energy sources you can think about now and in the future. And that's it. Thank you very much. John, over to you.
Thank you, Johan. Johan, I'd like to invite you and Philip and James to come back, and we will have the Q&A session. So Johan, if you can just move on to the next slide, I appreciate that. You still have control of the deck. Yeah. Okay, great. Thank you. Philip, are you there?
Yes, I'm here.
Great. James, you can come off mute if you're there. Thank you. Right. We've had a lot of questions come in. So I'd ask you please to be as concise as you can, because I'm not sure we'll be able to cover them all, but we'll go back to Philip's presentation. Sorry, actually no, James's presentation. So James, the question came in, first one I have here is BP testing WellView, brackets drilling data, WIT-S, WIT-SML data in Tele with OSDU?
I think in short, yes, we will. So we have a number of different well monitoring type systems, real time or otherwise. We will definitely be testing those types of systems with OSDU once we get it up and running in the company. Yep.
Okay, thank you. The next question, can we relate OSDU for our industry with similar initiatives to another industry, like for banking, like for the banking industry with SWIFT?
I think this goes further than SWIFT, because what we're offering here, SWIFT is very much an exchange environment where banks can talk to each other and can exchange data, can exchange transactions, what have you. This goes further. This also offers the data platform running, if we compare with the bank, running in the bank itself. Because these data platforms are run in the operator. If we do it with SWIFT, it would also have the data platform running in the bank. And of course, in addition to the data exchange. So I think this goes further than what SWIFT does, because of the whole story around your data platform, which is standard data definitions, which are the same for each of the companies. And in the case of SWIFT, they don't need to be the same, because the company can still have their own banking system behind it. Here, you use your data platform with the common standards between all the operators.
Yeah, I think you can relate OSDU to the Android operating system for the mobile industry.
Okay, thank you. Next question here is, can it be used for hydrocarbon accounting in future, if it's not already being used for that?
Technically, no reason why not. Hydrocarbon accounting is really about support for the data, and a lot of the data, of course, is already available for hydrocarbon accounting in the OSDU environment. And what is missing could be added. So there's no reason why we could not collect all the data you need for hydrocarbon accounting in the OSDU Data Platform, and have then the application sitting on top of the platform, making use of the data in the OSDU Data Platform. But maybe Philip, you have another comment on that?
Yes, as we move to the production, that's what our next step is, to integrate upstream. But it's critical to incorporate accounting so that you can really link the data to the value. And that will be critical as when we incorporate other energy sources as well. So it is a critical component that we will absolutely include that.
Thank you. Another question here is OSDU likely to be used in the mining industry? I know there was some mention made about moving this into other industries and other energy industries.
Yeah, we had a question about mining. It's very simple to do, because if you look at what you've heard this morning, the OSDU Data Platform is not specific to oil and gas. What makes specific to oil and gas are the data type we support. What is the data that we support in that platform? But the underlying technology, the way it has been constructed, it can be used in any environment. So yes, it can be used in data mining, but it would mean some other, because you will have in the data mining environment most likely some other data type support. Then we would have to add more data type support. We've not looked at data at mining. We had a question about it before, because our focus is, as we said before, but from a technology point of view, yes, it could be done.
Yes, the mining industry has a standards organization called Open Mining Group. Actually, we are in discussion with them to establish a collaboration with that group so that we can share the standards.
Okay, thank you. Another question here is OSDU sitting on top of databases like OpenWorks, ProSource, or databases sitting on top of OSDU? How do they work?
Yeah, the answer is no. We do not sit on things like OpenWorks or ProSource. That's all legacy. We really, if you look at an OSDU Data Platform, it really sits on top of cloud capabilities, like in the case of Amazon S3, like in the case of Microsoft AWS, and similar services with IBM, etc. For certain data, like for metadata, we'll use some sort of structured data source, but they're all embedded inside the OSDU Data Platform, well hidden for the user. We're using APIs, but do not assume that we migrated OpenWorks or ProSource, whatever, from the current environment to the OSDU Data Platform, and that's it. No, it's a very different story.
Okay, another question. Please, is R3 compatible with Azure Stack? Asking this to answer country data sovereignty issues for a private cloud approach.
Yeah, we're looking at the 4 cloud providers are all working on an in-country solution. IBM has one based on OpenShift, so that's available today. Amazon will come out with one later this Q2, and also Amazon so Google comes out with one later in Q2, and Amazon and Microsoft also work on them. In the case of Microsoft, I can't tell whether you use the Stack solution or something else. I do not know. It goes up to Microsoft how they want to do it, but they all have clear the desire and the task, but also the real desire to come out this year with on-premise implementations of OSDU Mercury.
Okay, here's one that's come in the chat channel. How are O&G firms integrating their physical archives into the OSDU? Are they digitizing well logs, reports, etc. to integrate into workflows, or is this untapped?
Philip, you want to start with that one?
No, I didn't quite hear the questions. Can you repeat the questions?
Sorry, I seem to be having a problem with my channel now.
Okay, I'll try to answer the question. It's about physical integration with OSDU. To me, that's untapped business, and it's really part of your data loading capabilities. So if you have physical data, and I want to let's image that data or digitize that data, well, that's really what it's all about. You want to digitize that data. Of course, the digitized data, you can bring it to the OSDU Data Platform. There's nothing stopping you and having a service out there, we say, okay, you have all this physical data. I'm going to offer you a digital data service, and I make it part of data loading and data ingestion services. You load it into the OSDU Data Platform. There's nothing stopping it. I want to have a stand solution today, but please, if you think an opportunity out there, it can be done.
Yeah, we just saw an example last week by Google. They actually had a parser-based, machine learning-based parser that can parse digital records and generating schema and ingest the physical records into OSDU Data Platform.
Okay, thank you. I've got one here. Does OSDU also enable for scenario modeling, sensitivity analysis, etc., aligned to climate change goals for enterprises?
That mostly look like an applications that you can develop on top of OSDU Data Platform.
Yeah, you need to really see what type of data do you need for those applications. Well, that's what the focus will be from an OSDU point of view, because of course the data can be loaded, but you need to say, okay, what's the data I need to run this AI application, for example. And then of course you have your data types, you make data definition, you load the data, and then of course you can start developing those AI applications as said by Philip.
Okay, thank you. We have seen 4 clouds were tested: Azure, AWS, Google Cloud, and IBM. So has OSDU finalized on any cloud?
I think they're available for all 4 different clouds for Mercury releases.
Yeah, we have no preference. It's just it's a market-driven initiative. We just support it.
Okay, thank you. Right, there's one specifically here for Johan. You had a slide showing data sources, R5000, PI, IHS, and an ingestion pipeline. Is this a one-time data migration from these legacy sources that will be retired?
Is that the question?
Yeah.
Yeah, well, in principle, we said it is a one-time migration you want to do from your legacy, from your on-premise environment into the cloud, because that's why I made the point a number of times that OSDU is a system of record. You move the data from your on-premise environment to the cloud via data loading, data ingestion services into OSDU Data Platform. Of course, it will take time, and for a while you will be in a hybrid environment because some of the data is still on-premise, some is in the cloud. But at the end of the day, when you're all done, the data will be sitting in OSDU and not in your on-premise data source anymore. It's purely an OSDU Data Platform as your system of record.
Okay. I've got a question saying, is OSDU deployment means that client will not need their legacy systems like OW, ProSource, Studio, etc. anymore, and will the client need to pay regular maintenance fees?
On the maintenance fee, we can't get any comment because that's purely a commercial question, and I can maybe if we want to do the other part of the question.
I think that it will be a transition period. You're not going to be able to get all the data into the OSDU in one go. And based on your business priority, you would live in a hybrid environment. That's why the application like Geologic SSIO is actually very important to you, because he can deliver OSDU data to your legacy environment as well.
Okay. Does OSDU store data in industry standard formats only?
No, both. Not only, because we have to be realistic. Of course, our preference is clearly industry standards, and we're really driving that. But if an application, and I won't mention names, is totally dependent today on a proprietary format, we'll support and install the proprietary format. We have to do it because we need to support the applications out in the end of the day. But our drive is, where possible, industry standards, common standards, because we really want to break that link between applications and data. But of course, you need to be realistic. That there will be still proprietary standards out there, but by making them available via public API, you expose more and more that vendor to having a proprietary format is not really, should not really happen anymore in 2021.
Okay. Could the marketplace layer move from commercial trade in application services to trade in data and information, or is that best left outside the OSDU for the time being?
No, there's clearly a market out there, because you think the marketplace today is very much geared towards applications. But of course, there's nothing stopping you over there to put in their AI applications. And of course, we already discussed with the cloud providers to also make it suitable for data trade. But is it ready for that today? No. Can it be made ready for that? Yes. For the end of the day, the marketplace, but remember, the marketplace is the marketplace of the 4 cloud providers. And if you look at some of the cloud providers, I won't mention names over here, but some of the cloud providers already support data trade.
Okay, thank you. Several demos showed how data gets selected and imported from maps. So all further data mastering is taking place in vendor apps. Is it a recommended pattern to master the data outside of the OSDU platform and upload it back once mastered?
Philip, or you want to name that one?
I think that in the OSDU architectures, we can support both. You can master outside, you can master inside. You can do your enrichment outside if you want to, but you can do your enrichment inside. So for the platform, it support both.
Yeah.
Okay. Somebody says here, making apps OSDU compliant can be a costly exercise, but software companies will jump on this as long as there is a market. As long as oil companies start to deploy and commit to OSDU, this decision becomes easier. Will OSDU provide an overview of oil companies deploying or using the solution?
I think this will come over time. Today is the beginning of this journey. As you heard from James, the BP is committed to deploying it. Other operator would come up with their own plan. So we will share as much as we can to the community from the operator side as we know it.
Okay, here's a question relating to legacy data. It says moving, say, 25 to 30 years of legacy data with so many different flavors of quality seems a daunting task to move it onto the OSDU data platform. What internal tools does the OSDU platform offer to facilitate this task? Or will I need to rely on third-party vendors and consultancy services to achieve the movement of 25 plus years of my legacy environment to the OSDU system of records environment?
Okay, I think this is the power of the forum. Very likely the company that working on your legacy data are also part of the OSDU forum. So together, this forum will provide services and product to allow operators to migrate this 25 to 30 years of legacy data to OSDU data platform.
And also it's important here, and let's be clear, the answer to the question also is both. So there are tools being offered as part of the data platform. I talked about data loading and data ingestion, but will it cover everything? No. So you also will need external partner integrators, etc., to help you with that. And of course, it's an open source environment. If you think I really need this capability to make my life 10 times easier, most likely not just your life, but everybody's life, you can bring it into the backlog, find some other people to work it with, develop it, test it by the PMC, and got it loaded and make it available to everybody. That's the flexibility also behind this. Think out the box, say, hey, I need this capability. It would make my life 10 times easier. Well, you have the capability to do that. Come out, speak to your partners, and make it happen.
And also, there's a tremendous opportunity for us to leverage automation based on machine learning to help to accelerate this process.
Okay, so here's quite a leading question. Is it free to use the data and applications on the OSDU platform?
The applications is in a competitive space. So all the applications belong to the vendors. The data platform is open source. So if you want to use applications, you have to purchase.
Or develop your own, but there's still effort involved in that.
Okay. How does the OSDU interact with IOGP Standards Committee?
We have a number of activities. We kicked off one, as I mentioned earlier. It's really, we look at what makes sense. So the one we have up and running in between IGP And there's a subcommittee ISP, but I don't have the name of that one. I think it's the digital one. And OSDU about bringing the engineering data into the OSDU Data Platform. That's a one-to-one we meet every other week, and it's really focused at that. And of course, we can kick off other ones where we see a need for it. I mean, we have an MOU, a memorandum of understanding between the IGP and the open group. We can freely exchange information. IGP members can join the OSDU Forum groups and what have you, and vice versa. So that's important as well.
Yeah, another key area for collaboration is the geospatial data.
Okay, thank you. Yeah. We have already overrun significantly. There are more questions. I don't know if you wish to take more, or if we will maybe arrange to have those answered offline so that people can access those.
Yeah, if you can capture all the questions
yeah.
Offline so that we can provide some answers.
We will capture the questions offline.
Yeah.
So on that note, as well as the questions being captured and maybe answered offline and made available to attendees, I saw a question somebody was asking about, can they see the demo sessions in the second part of the launch? That's where we're repeating this for different time zones later in the day. Both sections will be recorded and both sections will be made available to everybody who's registered for either of the events. So we have your information and you'll be informed how to access this information in a couple of days. We do have to take those video files, we have to do some work on them, and then they will be made available for anyone who registered for this event or the second launch event in a few hours' time, and you'll be able to see both sets of demos. Okay, well, thank you all very much indeed. Before everyone goes, I will say we're going to run the people video again, just to show you some of the folk who worked on this platform behind the scenes, so before we shut down. Philip, I don't know if you've got any closing comments you want to make, and then
okay, thank you.
Go to the
thank you, John. As I said in the beginning, the Mercury release is the beginning. I think the Mercury release allow us to scale up our collaboration in a big way. I look forward to engaging with all of you in the coming months. So I'd like to thank the Open Group for hosting and supporting this event. Many thanks to the keynote speaker and all the presenters, including the video presenters. And a special thanks to all those who actively contribute to the code base. And we can't do this without OSDU focal points, OMC members, PMC members, and technical subcommittees. Again, thank you for joining this launch event. Have a great day.
Thank you.